Yeah, that was one of the things. I was looking over my shoulder when we were leaving. One problem decided to go back.
Yes.
I decided to do 15 plus 3 instead of 7.
Okay, folks, this is the LISP working group session. My clocks claim that it's time for us to get started. If you're not here for LISP, please move somewhere else or sit and watch. You're welcome. But that's what we're going to be discussing in this next room for most of the next 2 hours. This is the note well. Please note it. It's Tuesday. You've probably seen it a couple of times, but it matters. So this is the note well. We're now moving on.
Yeah, whatever you say from now on is a contribution to the IETF. There you can see the usual pointers to the charter, the Jabber room, audio stream, Mitico, and agenda and slides. I'm Luigi Iannone, Joel Alper. We are the co-chairs here. Padma sitting in the room is our secretary, very helpful. Okay, this is the working group status issue. We will quickly go over it. We have 6834 bis. It's a little bit stuck in the sense that we are waiting the main specs to go out to revise this document and send it forward. It passed last call, but we have to check that is compliant with the changes that we did. LISP GPE, we will have an update later on. Introduction has done for something like a few years. I can't read how many days anyway, but a lot of time. Then we have the 2 BIS documents, the main specs. Albert will give us an update on what is the status. Okay. 8113 BIS passed, misreference stuck in the RFC editor queue. We have LISP sec. Now, this document is slightly in a peculiar position, because he has been in working group last call for like 3 months or so, right? Reason is that we went for the last call, then Ben jumped in with comments and things to change. So we waited for the authors to change it. They have done it for a long time. So I think we did not receive any more comments, right? So we'll send out an email on the mailing list. Unless there are objections, we will close the last call in 1 week from now, so next Tuesday, and then move it forward as usual. Okay. In the meantime, we will check with Ben if he's okay with all the changes that have been done. Okay. Then there is the LISP vendor LCAF. This is past the working group last call. Is parked, waiting for the Shepherds write-up, which is me. But we are giving priority to the main spec. Okay. So agenda. I will take 1 minute to talk about 7954 and 7955. Okay. And then we will go over the update for the BIS documents, LISP GP. As I said, these are the 2 working group, the 3 working group documents we will discuss today. And then we have 3 non-working group items. LISP overlays, Mark will present. Dino will give us a demo about mobile node, Multicast. Last time he gave a demo only about mobile node, Unicast. And then Sharon about distributed geospatial LISP blackboard for automotive, okay, the H3 stuff. Any comment about the agenda? No? So let me get quickly to 7954 and 7955. So these 2 documents, one was asking Ayana for a specific prefix, IPv6 prefix, to be used experimentally for LISP, okay? And the other one were the guidelines how to manage this block, okay? And RIPE and CC very kindly take over on the management of this block, okay? Now, the experiment, the experiment went over for 3 years, okay? The deal was in 3 years, if we don't have sufficient demand for the prefix blocks, and there is no specific action from the IETF, then we give this block back to IANA. So we had few requests about EID prefix, okay? There was no specific action, so it's time to give back this block to IANA, which happened in September. Now, what do we do with these two RFCs? Okay, so the most reasonable thing to do is to make them historic. In this way, we can add to the two documents a note, which is the one you can see here on the screen, that explains why these two documents are historic. Okay, so this is the text that has been discussed by email. In red, you can see the most important part, which are the two RFCs, the fact that the experiment should run for 3 years until September 2019, and what should be done if nothing happens from the IETF side. So, and at the very end, there is a sentence that asks to put the two documents as historic and add this note to the process. Okay, so that if for whatever reason people read these documents and they are looking for the EID prefix in the IANA registry and they will not find it, they know why. Okay, we keep track of the experiment. Okay, so we'll send this text on the mailing list as well. Okay, if you have any suggestion or correction to do in the next week, please send an email back. Otherwise, we will use this text to make these two documents historic. Okay? Any comment on that? Great. Oh, Padma?
Padma. First of all, I missed this discussion because I was away, but there is one thing, is that we actually have the anonymous EID draft that was actually using a portion of, I believe, these EID prefixes. So,
Which draft? I couldn't quite hear.
anonymous EID. EID draft.
Well,
So, yeah. So
then we'll have to find
need
some other
go-
address to use.
Yeah, we'll need to find out what we're going to do next. Of course, it is possible to maybe ask for another range or change the range, but I wanted to let you know that, yeah, there is a draft.
From my perspective, there are two ways forward for this document. So one is, do you really need an allocation from IANA? In this case, you may ask one in the document itself. Otherwise, you just can specify the fact that maybe an operator should reserve a prefix to use it from the anonymity stuff.
Yeah, so here's there's an advantage and disadvantage to each one of those. The advantage of having a IANA pool is that all operators may use that pool. If you have it and you have a better anonymity, if you have each operator giving you a poll, you won't have as much anonymity as that.
This is Dino. The reason we needed a well-known allocation is because if we wanted the rest of the bits of the address to be a hash of the public key, and we wanted an application to use that to look up a public key to verify signatures, it would be nice to know that it's not an opaque address or an address that's assigned a different way, but it actually is a hash.
The only comment that I can say, okay, but not with this prefix, it's too late. So there is not that much that we can do at this point, unless you want to restart all the process, which will.
Okay.
I think we're fine with that, but I wanted at least so that this is known that
Will be in the minutes. So next, Albert.
Okay, so I'm describing the usual update on the 6830Bs and 6833Bs. So since last IETF, we have posted 2 new versions, and we have addressed roughly 160 discussed and comments. And as far as I know, we have addressed all the comments. Now it's up to the reviewers to tell us if we have addressed them right or not, but all of them have been addressed. So the main changes I will discuss first the main changes on the data plane. The first one is on locator status bits. We have fixed a behavior that occurs when a locator is added or removed from the locator set. Then when this happens, the source XTR, the one which is setting up the LSB, can no longer use LSB for a timer. So it will set up a timer, and it will at the same time send an SMR to the destination XTR, which means the receiving side of the locator status bits. Then the receiving side of the locator status bits will refresh the mapping, and after the timer expires, the source XTR will be able to set the locator status bits again for use. So that's described on the updated version. Then we have clarified also the map versioning requirements regarding synchronization, that basically the ETRs within a Lisp site needs to be synchronized within a 1-minute window, which was a requirement from the reviewers. So this paragraph is verbatim on the spec. Then there are many other minor edits and comments, and probably the most important one is that we have removed references to traffic engineering on the IETR definition because it was not properly introduced. We have also removed the definition for negative map cache entry. Also TE-ETR and TE-ITR. We have stated the meaning of the instance ID, just saying that it's informally the participants on a Lisp deployment must agree on the meaning. We have also clarified when the information may be cleaned, and there are a bunch of other edits. Then regarding the data plane, the control plane, sorry, we have also clarified when the A-bit authoritative bit can be set in the map reply. We clarify that we don't specify a strict meaning for the site ID field, and informally it provides an indication that a group of XTRs have some relation, administrative, topologically, or otherwise. We have also clarified, and I think that's a good catch from Ben, that authentication data is recomputed and verified both in MapNotify and MapNotify ACK. And we have completely removed the section describing locator set compacting because it's no longer need because of the first slide regarding locator status bits. We have also removed any reference to BGP since it's not consistent with the new scope of the applicability. Also reference to Lisp alt because it was a sense of some kind of privileged mapping system, which is not. The control plane can work in any mapping system. We have clarified several aspects on the security consideration and many other minor edits. So this is the status right now, which is the same as on the last IETF. So we still need Benjamin and Mirja to tell us if the changes are good or not, and that's it.
Question or comments? No.
Fabio Maino. I just wanted to thank Albert for taking care of the comments because it was a massive work, and all the comments were incorporated in the discuss in one of the last review we got, and yeah,
Thanks.
It's been painful.
I joined Fabio on that because
Thank you.
160
We share the pain.
comments and the discuss, it's huge work. And you did a good job. I was up to ask to push a little bit Miriam and Benjamin so that they go over the changes again and let us know if they're fine or not.
It's Deborah. I also thank you for all your work. And I encourage you, try this week to get with Maria and Benjamin to encourage them to look at this. Because what will happen in 2 weeks, everybody will start taking the Christmas holidays, New Year holidays, especially Europeans go skiing. And Miria will not be on the ISG next year, right? So we got to get this done. So I really encourage you to in these next week, 2 weeks, get them busy with it.
Will do. Thank you.
Thank you.
So GPE, just as a quick note on GPE, this document was last called a while ago, was under review at the ESG. There were a few comments and changes that we teachers believe are important, and so that the working group has to be aware of the changes done. Okay, so it's just an update, but we are not going through again the same process. It's just an update on what happened.
Okay, so I'm Fabio Maino, these are the co-authors, and this is Singapore, I guess. So these are the changes I tracked since 06 because there have been a couple of versions that were minor, but the relevant changes are between 06 and the current version. These are the main changes. We remove support for non-smart versioning and LSB. I'll go then through each one of them, okay? So I'll get back to this. We introduce the concept of Shim headers. Then we introduce a new section 4 that is about implementation and deployment considerations. And then there is, we did some changes on multiple data planes encapsulation bitmap registry, and we need to do a few more. And hopefully the presentation of today will clarify what is the changes that we need to do. So Ben and a few other reviewers pointed out that features like eco-announcing and map versioning were relying in LISP-GPE on fields that were even smaller than what we had what we have in the LISP header. In particular, we have only those 2 bytes marked as reserved now, and particularly for the nonce, even for map versioning, that was complicating the features as well. So since we have the opportunity with LISP-GPE of introducing new feature in the form of Shim headers, and we will see what we mean afterwards. But in general, since GPE is an extensible protocol, then we thought that the easiest thing to address those challenges was to basically remove the features from the main header. And if we want to, it is possible to redefine headers that will follow the LISP-GPE header that implement those features. For example, if one wanted to use a nonce of 64 or even 128-bit, one could do it. And the same for map versioning, and the same also for LSB. So rather than trying to live with the limitation in space that we had in the original LISP header, we can try to use the flexibility of GPE to deploy ad hoc headers for those particular use cases. So this is the new text here, and basically this is what we do. We got a comment back from Ben saying that this is he agreed that this could be a nice way to move forward. So hopefully this will help him to go into a yes for this document. Shim headers. So the other change was introduced because we realized that there are some features that can be used, and I think this was a comment from Miria that started this change, that it is possible, I mean, the LISP header is full of features, but we kind of run out of space, and there are some features that can be added to the LISP-GPE protocol, and if we make the format of the additional header that we can add with LISP-GPE fixed, it is possible for implementation to implement, of course, the extensions that are well known at a certain point, but it is also possible to skip those features that are not known at the moment a particular hardware implementation, for example, or software, for what it matters, is defined. And this is helpful for intermediate nodes because in this way, one can deploy incrementally features that we add to LISP-GPE, and the intermediate nodes don't need to be changed because they can just skip the parsing. Let me show the how the Shim header format is, and you will understand that this is fixed. So whenever we want to define a new Shim header, please.
I understand that the Shim header, but we don't have transit nodes. The closest we have is RTRs. But we don't. But RTRs technically terminate a tunnel and start a new tunnel.
Right.
We don't have any transit nodes.
Right.
I've noticed this coming up in a number of overlay protocols where the protocol runs between two endpoints and somebody starts worrying about what is the transit node doing? No, let's not make any argument about transit node behavior, please.
Okay.
We don't have any.
Okay. Go.
Do you know? You have a clarification on all ears.
I'm just wondering if he's talking about, is it, your comment's very right about RTRs, but could there be nested headers? And are you applying for a nested header that it's a transit?
The nesting header is just the endpoints of the tunnel.
I just want to know what.
In general, I think
that.
what it could be helpful is that, when parsing, even at the, we should write more clearly that, and I agree with your reference on transit nodes. Maybe what we should specify is that at the tunnel endpoint, at the ETR, with this structure, the implementation can parse in hardware, all the headers that have to be parsed in hardware. And, for those that were not defined at the time that the hardware was designed, the packet can then be punted in software, and those can be taken care in software. So I agree. I can rephrase that, and that's a good...
Doing it in terms of ETRs is just fine. It was just the transit header caught my attention. Is like, no, that's not what we discuss here.
Yeah, that's a good comment. Okay, so I can do the change and change. Actually, I think this text has not been added yet, so I'll change accordingly to what we discussed here.
May I? Would it be enough just to drop the transit word and say LISP-GPE nodes or the LISP-GPE ITRs, XTRs?
I think so. I think if this thing can become implementation that are not aware of a given Shim header, of a given Shim header type, must ignore the Shim header and proceed to parse the next protocol. Yeah, exactly. And also I can change the reference in there. Okay, so we will do that. Thanks for the comment. And that is it. The other aspect that may be interesting of Shim headers, I think to help hardware implementation that have to allocate some buffer for these particular features, having these headers in front rather than at the end help. So the Shim headers that use a certain range of the next protocol field, they will be in front. And this, I think, is just a simplification for the hardware implementation. Examples, I have removed all the normative reference to examples, but the draft is actually mentioning that, for example, what you could do with Shim headers is define support for GBP, group-based policies, IOIM, eco-nonce map versioning, and LSB, of course, and there is a sentence specifically for nonce map versioning and locator status bit. And this is just to provide the example of what can be done. But there is no more normative reference to this draft, and also the allocation of the code points for the next protocol will be done in the specific draft. And this was to address Joel's comment. We have a new section 4, about implementation and deployment considerations. So there were a few comments about congestion control, how to handle the UDP checksum, TOS bit and PCP bits in the Ethernet frames that were still part of section 3. So actually, there is a RFC 885, that specify well what are the UDP guidelines for tunneling protocol. So what we have done is basically look at RFC 8086, that is GRE in UDP encapsulation. And RFC is basically referring to RFC 885 and, following the guidelines of RFC 885. So not most, but some of the text that was in RFC 86 could be, basically easily ported in this case. And that's what we did. So we have this section 4 where we have an applicability statement. We have comments about a section about congestion control functionality, the usual UDP checksum and UDP 0 checksum with IPv6, and then consideration about Ethernet encapsulation payloads. So the applicability statement, I think, is the most important of this section here because according to RFC 85, there are two applicability scenarios for UDP application. One is when the tunneling protocol is designed for general internet applications, and the other one is when it's designed for a controlled environment. According to RFC 885, a controlled environment is what is defined there. It's a single administrative domain or an adjacent set of cooperating domains, and where a network is in a controlled environment and can be managed to operate under certain conditions that don't apply in general to internet. The requirement for a protocol, a tunnel protocol that ends up in the controlled environment scenario are less restrictive than the requirement of general internet. So if we go back to RFC 6830 we see that the LISP scope of applicability is what RFC 885 describes are a traffic managed controlled environment. And so LISP GPE has the same scope of applicability. And so basically this section is mentioning that. In this case, we can basically refer to the second, to the TMCE scenario, and that simplifies the requirement for the tunnel protocol. Okay, and this is, the change. Please take a look at section 4. Send your comments. Most of the text, as I said, is coming from RFC 886, so it has withstood the time at least. Then the last aspect. This was particularly complicated. For some reason, I couldn't understand many of Luigi's suggestions, but I think we got it now. So LISP-GPE is defining the use of multiple data planes, and there is an LCAF type that is actually specifying how an ETR can signal in the map reply which encapsulation are supported. So all is fine and nice and dandy, but that particular LCAF type is not really allocated as part of RFC 8060. So it means that if we wanted to refer to the LCAF type used in RFC 8060, this would be a down ref to an experimental RFC. And this is a big no-no because, we are defining LISP-GPE as a proposed standard together with 6830 and 6833 bis. So the thing to do is basically say, okay, let's take out of scope of LISP-GPE the detection of ETR capability. So I will replace section 5.1 with a simple sentence that will say that the detection of ETR capabilities is out of scope of LISP-GPE. And we will leave that kind of work for when eventually RFC 8060 from experiment will be moved to proposed standard. And that's the plan. So
I have a comment. I think this is coherent with the previous slide when you say we still deploy Gobi before, here, because it's a controlled environment, right?
Okay.
And if they are connected over the public internet, still connecting controlled domains. So if the domains are controlled, you have a way to know who is using
the behavior
GPE or not.
Okay.
So it makes sense to leave it as it is. Simple.
Yeah.
For now, at least.
Okay, that's a good comment. Yeah. Okay. And yeah, so next steps. So we have a few action items, the comments from Joel, section 5.1. I think there are a couple of, I've seen actually one typo in the actual test while I was presenting the slides. So we will address those and we will publish Rev 12 tomorrow or the day after tomorrow. And that's it. And the document will be ready for your review. And then I guess, and you guys please confirm, we will send the document back to last call for the working group to come, right?
Yeah.
Okay.
Any comments from the room?
Okay, thank you.
Okay. Hopefully in 2-3 weeks we can be past the last call and move forward. Thank you.
They're putting deadlines.
I'm putting deadline on myself. Yeah.
Good, thank you. Mark.
Okay, Mark.
There you are.
Okay, so this is Mark here to provide an update on the changes we've been doing to the Lisp overlay draft. Yeah, so this is an update based on the feedback that we received in the last meeting in Montreal. I think the most important change in this update is the discussion on topology considerations. I think you had multiple comments back there. We have also included a couple of other considerations here. These are based on implementation aspects that we've seen while trying to put this in practice. Okay. And yeah, we've also added some editorial comments. And yeah, I have this sentence that the revision 02 would be posted soon. It just got updated. I think Victor posted it, so you'll find this text already in the website. Just to recap, what is the overlay draft? If you remember, this is a draft to provide interoperability as interoperability between site overlays that are disparate, that are running disparate implementations. This disparity can come as control plane disparity, or different control planes, or different data planes. And the basic proposal is, or what the draft tries to propose is to structure this interoperability as a hierarchical structure, where multiple sites are connected through these transit overlays. Okay? This is just the recap. But the important thing is what comes in this version, and the most important update is this topology support discussion. The idea here is trying to answer how do we stitch together multiple networks that are running these overlays. Okay? And what the text proposes here is this concept of loop-free topologies. Right? The most important aspect that we are saying in the draft is that there is no provision for the detection of registration loops in overlay deployments. Okay, when we concatenate multiple site overlays and overlays, and given this, the draft tries to enforce the idea that overlays must be deployed in a loop-free topology. In loop-free topologies. What does this mean? And these are the next slides. Okay. Maybe let me skim through this and go straight to pictures that will make it easier. Lisp loop-free topologies mean is that, okay, first thing, as we said, right, overlays are proposed in this hierarchical structure, or the idea to deploy overlays is to follow this hierarchical structure where we have site overlays connected to overlays, and these overlays could potentially be connected to higher level overlays that could provide this interconnectivity between distant or separate site overlays that are connected to different overlays. Okay, but the important thing in this loop-free topology is this, right? That we impose two connectivity rules to this hierarchy of overlays, where overlays that are at the same level should never connect to each other, and overlays of any type should never skip hierarchy when connecting to overlays. Right? If we impose these two rules, we guarantee that there are no loops in this topology. So we are free from having to find routing solutions to the connection of overlays. Okay. Yeah. If I go back to this, the draft presents this loop-free topology as a generic concept. It's not encoded in the protocol in any way. Yeah. And then it goes and defines these two rules on how to connect overlays. Yeah, I don't know if you have comments on topology. This is,
Hey, this is Dino. If somebody happened in site overlay 1 point to a map server in the core overlay, and it's against the requirements of the draft, I think, but I'm not sure, maybe you could answer this, is the site ID that's being registered could actually be known in the core overlay.
Okay.
And when it registers to overlay 1, it knows it can do the loop detection. You might be able to prevent this dynamically without any special, anything other than what you've already specified. Do you agree?
we could actually, next section talks a little bit about how to use site IDs for this, but I think we could still find cases where we may be able to break it.
So clearly the draft says you shouldn't do this.
Yeah.
But if somebody accidentally does it, does the machinery actually keep the network together?
It's not, the machinery isn't going to take care of the horizontal links at least, so they need the
Yes.
rules anyway.
Yeah. I think site IDs can potentially help here, and we could maybe, and this comes with the, I mean, this relates to the next slide, right? That it's what happens if we have multiple borders interconnecting multiple sites, right? Well, or a site and an overlay. And here we have another instance of a loop in some sense, right? So the idea is that, okay, we have a border set that it's logically connecting two sites, and yeah, I think the image is always better. What could happen here is that depending on the order of events, what we could have is that one border learns a mapping from an overlay before the other, registers with the overlay, and for whatever reason, this registration comes back to the other border, and this would create a loop back to the original site. Yeah, the update also brings a provision to solve this, and the idea here is that we need to treat these groups of borders as a border set and implement split horizon rules to the registration process. If this could help prevent the unexpected configurations or unexpected interconnections between overlays, I should reevaluate a little bit, but could be. But yeah, the proposal here is that members of a border set need to share the idea of site of origin when registering prefixes. And how they do this is, yeah, I know that at the beginning you mentioned that site ID is not, yeah, it's been specified a bit abstract in the BIS draft, but here we try to go back and give a more specific use to this site ID number. And the idea is that what this draft proposes is that site ID identifies the origin from where EIDs were learned by, let's say in this case, a border set, when registering this with another site. No? And as long as as we keep the site ID through the registration and publication process, we can implement the split horizon solution. Yeah.
Another question for clarification is the site ID is bound to the site from which I learned the mapping, or is the site actually publishing the mapping? There's a slight difference.
Yes. So it identifies the origin, but it's meaningful in the destination, let's say, site where you send the registration. Okay? But yeah, so it's a number in some sense that both border XTRs that are redistributing EIDs need to share in order to be able to implement the split horizon.
So it's more than just locally significant to the site. Your phrase here on the slide is locally significant to each overlay, but it's used by other sites.
Actually not. It does not need to cross site boundaries.
Okay, you just said it was used across sites.
No. So we have a border set. These guys are, so let me go to back. These two guys are connecting these two overlays, let's say, right? The overlay and the site overlay. Now, in the overlay, a site ID will identify that prefixes come from site overlay, but this number is only significant for the two borders, and it must be unique in the overlay, but does not need to be unique. The site overlay does not need to know anything about this. It's a number that these two borders share in order to recognize registrations that they have made and that have come back to the same border set.
Okay, so it's used by the borders from this site in case their registrations get reflected from somewhere else.
Yes.
So it's carried opaquely. Okay, yes.
Makes sense? Yeah. Okay.
So can you go back to the diagram?
Yes.
Well, but there is a requirement then in order to make it work, different sites better manage to nonetheless use different ones. Even though they're locally significant, if two sites collide, very bad misinterpretation will happen. So it's not quite locally significant.
It's a 64-bit number. That's a random number. So
It's unlikely to collide.
Yes.
But we got to be careful in how we describe these things.
So I have another quick comment. To me, it's a little bit misleading how you have the things going 1, 2, 3, because what's happening is the XTRs are registering to MS1.
Okay.
Right. And then the BXTRs are registering all the EIDs from the site overlay to MS2. Right.
Yes.
So you have an arrow in number 4, MS2 back to XTR2. What is that is that a message? It's not a map register because BXTR2 is not a map server.
Well, it could be a published message, right? For example, so the border XTR2 is subscribed to receive everything that is registered on MS2.
Are you saying MS2 sending a map notify message to XTR2, telling them about things that have been registered to it, which could have came from other site overlays, but could also come from itself, and therefore you shouldn't re-register it to MS1 because XTR has registered it.
Yes.
Okay, got it.
Yeah, we could also have partitioning, right? I don't know. For some reason, traffic is sent through border XTR2, sends map requests also. So any sequence of events that can lead to this. Okay, so yeah, local significance. Yeah, but I think the important concept here is the site of origin and the relation with site ID. That's and the last one is this idea of default DID registrations. The idea with overlays and stitching together site overlays is that in deployments we assume that borders receive most of the traffic following, for example, negative map replies saying, okay, prefixes, in order to prevent an explosion of registrations, we may choose to not register everything with site overlays and kind of use a default route when accessing prefixes that are outside of the domain of the site overlay. Okay. So this default DID registration is just a provision so that these negative map replies can be converted into complete mappings, and carry a group of RLOCs that correspond to the borders. Right? And it's just so the basic idea is that this is registered as some other type of VID, just so that the map server can continue computing negative map replies, and dynamically.
Yeah, this is Dino. I made a comment to Victor that if a map reply has an RLOC set in it, by definition, it's not a negative map reply.
Oh, yeah,
so we should use the right terminology.
Okay. Yeah, I think what we wanted to say here is that the calculation is the same as for negatives, but then we send the complete mapping back to. Okay. And that's it. Do you have any other comments or questions? This was just uploaded. You can find all these texts in version 2.
Coming back to the question, to the comments of Dino, that would be a proxy. That's the terminology to be used. Then the proxy can re-encapsulate me if it wishes, but is that correct?
I guess anybody who sends a map reply that are not their own RLOCs are advertising RLOCs of somebody else. And yes, you can call that a proxy map replier. So it's a great term because when a map server returns a map reply on behalf of an ETR, it's a proxy map reply per definition. And it turns out that the RLOC set that it's proxy replying for are the ETRs that are at the site. So yeah, it's perfect. Yeah.
Oh, so you're suggesting we update with proxy? Okay. Yeah, that's good.
He's right on the clarification of the terminology. I agree with you.
Okay.
So proxy might be
better. Okay.
Yeah. Okay. Thank you.
Okay.
There should be.
You want to grab the cake. You always want to grab the cake. So,
I have to send some objects. Okay, good. That's great. Okay, I'll do this. Am I standing in the wrong place then?
Yeah.
Okay.
It's not very for you.
Okay, so I'm going to give a quick multicast demo on a Lisp mobile node. At the last IETF in Montreal, I gave a unicast demo, and basically what it showed is that a mobile node can switch from LTE to Wi-Fi with session continuity because the phone is allocated an EID and talking to an EID or a non-Lisp site on the other side. If you want to see that unicast demo, I'm going to give the unicast and multicast demo at MBOND on Thursday, I think it is. But this is just going to show the new stuff that I just started playing with. So what we are demoing is the Lisp mobile node draft 5 on an iPhone. And I have some RTRs re-encapsulating tunnel routers that are deployed in Google Cloud. And the Lisp mobile node is going to talk to Lisp correspondent nodes behind NATs. And for this demo, the multicast sources and the multicast receivers are all in the Lisp overlay. So there's no inner working per se. that's part of the mobile phone demo. But the very last slide is we're doing some work with MBOND on interoperability with AMT, so I'll talk about that separately. Okay, so some magic sauce. The Lisp mobile node is not running any Lisp control plane, just like in the Unicast case. So the Lisp mobile node basically, when configured, has a map cache for all routes going to these RTRs that are in the cloud. And the RTRs are configured to glean XTR mappings. So we don't have to use any NAT traversal control plane. All the NAT traversal logic happens in the data plane. And this is in an effort to implement a really very lightweight XTR, maybe ones that can run in dash cams and low memory and low CPU challenge devices. Okay, so when the Lisp mobile node is acting as a multicast receiver, that means it's a member of a group. It's using IGMP to join groups. The application that's running on the phone will send IGMP reports. Those IGMP reports are encapsulated like any other packet to the RTR. And then the RTRs track the group membership. The RTRs then replicate multicast packets to all the Lisp mobile nodes that are group members. Head-end replication is head is a relative term here. It's the RTRs that are receiving the IGMP reports from the mobile nodes. When the Lisp mobile node is a multicast source, it sends multicast packets just like any other packet to the RTRs. So as you can tell, the Lisp mobile node does absolutely nothing. Any application data packets always get sent to an array of RTRs or one RTR if it's configured with a single one. And of course, the RTRs can replicate to correspondent nodes or Lisp mobile node group members. Oh, I missed a little bullet. Sorry about that. Oh, so what happens is by doing this, Lisp mobile node maintains multicast session continuity. So if the mobile node is moving across LTE and Wi-Fi locally, it's either losing signal or you're switching the multicast streams, either being sourced by the mobile node or receiving as a member, keep going. So here's the topology we have set up. I have two containers that are running on my laptop that are EIDs 25 and 14. They're sitting behind NAT devices, of course, because they're running in Docker here. So there's not only a NAT on the laptop, but there's also NATs depending on how I'm connected to the internet. And the iPhone is running OOR. So some kudos to Albert and his team for doing the OOR implementation and supporting me through this. It's been really a great thing, so I appreciate it. So the mobile node is connected to Wi-Fi and LTE, of course. It's EID 13. And the idea here is that we're going to use those RTRs that are sitting in the internet underlay. So the GRTR is the one in GCP, and there's 3 other ones in AWS that they're there to be used. They were there for the Unicast demo, but we're not going to use them for the multicast demo. We can, though, with some issues that I'll talk about. So the first demo, or there's 2 streams we're going to do. We're going to show that the 25 is going to be a multicast source sending to group 224.111, and it's going to be running VLC as the application video streamer. And then we have a copy of VLC that's on the iPhone that's running, and it's going to be joined to 224.111. And then the second demo is we're going to have the phone be the source, and it's just going to be sending pings to 224.222, and we're going to show that the 2 containers are joined to that group. Okay, clear? Okay, so I'm going to fire up this demo. I'm not a film expert, so there's a little bit of touchy filming here, but and so don't laugh when you see what happens. Okay. Oh, hold on a second. It's not letting me. It's not letting me go all the way up because it's in some weird presentation mode. Okay, let's try it. I'm hearing audio coming out of here.
Yeah.
The audio setup here is not what you think it is.
Well, it didn't do it last time. Okay. So I'm going to have to do this myself. Yeah, sounds good. Okay. So let me go back real quick and click it. Oops. Okay, so I think we're first going to do the ping, and I'm describing basically what I just described to you guys. And when some action, I'm just pointing, saying that this is the source, and it's going to send to these two receivers. So we're doing the ping. That is a shell window up there. And I blew out the projector. There. There? And I guess it's starting, and I can't rewind. Show navigator. Okay. I hope it doesn't time out. While it's running, could you just do this to keep it going? Oh no, that's not going to work good. I don't know. It's this presentation mode. Let's do it this way. Yeah. Is it moving? Okay.
You have to move the window to the screen or mirror the screen.
Oh, great. There's too many problems.
There, you're back on the screen at least.
Okay. I wish I could fast forward, so let's see. I'll keep the pointer up there. And while I'm describing it, just do this a couple times so the screen stays refreshed. Okay, it's only a 3-minute video, but okay, now we're back where we were. So what's going to happen here is we're going to ping 224.222, as I'm showing there with the arrow. If you can see it from back there, I'm not sure. And then these are the two containers in this window. So once the ping starts, these guys are joined to the group. I'll show you that when I show you the RTR display in that web browser. I'm telling you now that the two containers are joined to the group, the 224.222. These are their RLOGs, and these are their EIDs. Of course, their EIDs aren't important here because they're receiving data from 224.222. Now I'm starting the ping on the phone, and you see the scrolling happening. And then when you come here, I'm refreshing the display to show you the packet count going through the RTR. So it's replicating to the two containers. This is happening. The containers, the receivers, and the source are both at my house using my Comcast connection. So they're actually going all the way to GCP and coming back. And so there's a lot of delay. So the RTR is really, there's really a lot of hairpinning going on. Now what I'm doing, I was on Wi-Fi. What I'm doing now is switching to LTE and showing that the pings will continue as soon as I move my hand out of the way.
Is this the funny bit? Or is this the funny bit?
Oh, no, it's not the funny bit. It's funnier is coming up. Okay, so now what you see is, now I'm on, let's see, I'm going to refresh the screen. That 73 address was my Comcast Wi-Fi. Now this is a 166 address, which is my phone connected to LTE. Okay. Now it's interesting here because it's acting as a source. The gleaning of the source here is not really that important because there's really no packets going back to the cell phone. This is really a unidirectional multicast flow from that's the funny part. I had my iPad as a camera on an easel, and I knocked it off. And I was quick enough to put it back up where you hopefully didn't see it. Okay, so what I'm doing now is I'm setting up this container here to send the video. So we're doing the video demo now. And now I'm going to bring up VLC on the phone right there. And when I touch when I touch the 224 network stream there, that's causing the IGMP report from the phone to be sent to the RTR. So that's, I'm about to tap it, and there's the stream. It's sending a waterfall video image from this container, and there you see it on the phone. Okay, and then I think I'm going to show you the RTR now. Now what you're going to see is 224.111 is joined by the phone, and you notice it's sending it to the 166 address, which is over LTE. And then I'm refreshing the screen to show you that the count, when the counters are dark green, that means a packet is received in the last second. And now what I'm doing is I'm switching back to Wi-Fi to show you from the receiver's point of view that the stream is. If you hear that static, that's actually the noise of the waterfall coming down. So the audio is being multicasted too. And now there's the waterfall, and then when we refresh the screen, we went back to 73. 224.111 is now in 73, which is the Wi-Fi connection. And that's it. Okay, so some observations. The glean latency does not exist as it does for unicast. So the idea is when the phone sends a packet to the RTR and it gleans the RLOC information via the NAT, through the NAT, that information is gleaned and has to be set up in a map cache entry because when a return packet comes back, it uses it. But since we have a unidirectional multicast flow here, we're really not sending unicast packets back. So for sender-only nodes, you really don't have to glean. For receiver nodes, you have to glean, but the gleaning happens at the control plane, not when you need the data. So the IGMP report that is sent from the phone to the RTR, that the gleaning is done there. And there's no way that the receiver can receive the traffic until the IGMP reports. So it's great. The reporting, the group membership join, and the glean happen exactly at the same time. So this is kind of nice. This is where, since multicast is your head upside down, we were able to take advantage of this receiver-oriented. So there is an interesting issue. If the members are spread across RTRs, then the LISP mobile node needs to send to all RTRs, which means the LISP mobile node would have to replicate. This is probably not good because of spectrum usage and stuff. We really want the mobile phone to send one packet into the infrastructure and have it replicate. So as you see down there, what we could do is we can use the techniques that we have in the LISP RE draft for replication engineering on how to place RTRs and how to replicate. But by default, OR only hashes to one RTR. So we can't get it to replicate even if we wanted to, but we don't want to. So we will not request any changes to happen there. No feature requests, Albert. But an upstream RTR can replicate to downstream RTR. So I just drew that diagram. If the source, I put a container here, but if it was, if a source is sending, it could send to a single RTR. A mobile phone could do the same. And since these guys, these two iPhones are IGMP reporting to a different RTR, these phones are configured with different RTRs, they join them separately. So what we do is, rather than replicate 4 replications happening at the source, or 4 replications happening here, we can do 1, 2, and then 2, and break it up. And this is the sort of stuff that we talk about in the replication engineering drafts, which I think are now expired, but so we can get that to work. And if people care about that, I could show a demo at next IETF if you want to do it. Mark? Go ahead.
No, just a curiosity. So if a receiver is multi-homed, do you have a provision for designated
Great
order?
question. Well, it turns out, at least iPhones, I don't know about Android devices, they have multiple connections, but they only use one at a time. And sorry.
That is one of the things they're working on changing in 5.
In iOS or in general?
In general.
Oh, okay.
They're moving. That happens to be true, but it won't. You can't count on that going forward.
Yeah. So the trick there is, where will the application sends the IGMP reports if it's multi-homed? If they're both active at the unicast, this works just great because you could load split on outbound, and who's encapsulating to you can load split on receive. So that's just basically the original LISP problem statement was doing multi-homing, service provider multi-homing. So unicast not a problem. In the multicast, it depends on where the application is going to send the IGMP report. And today, most implementations I've seen, IGMP reports aren't sent on multiple interfaces at the same time, because if it is, there's a good chance duplicates will come down. So you want to avoid that. So that's kind of TBD, still researchy. Well, we don't know what the implementations do. Should we specify it? Good question.
And
There's also the ways they're talking about using multiple interfaces may make it transparent to you, because if it's all under the same, I forget what, G node B or something, then it'll take care of it and it'll look like one to you. But there is definite support for even splitting, but simultaneous use of Wi-Fi and 5G. So this is something they're all looking at, but it's all ongoing.
Now, I would argue that if the IGMP report was being sent, let's say this is one iPhone with two interfaces. If the IGMP report was being sent to an EID of the RTR, then the RTR can see there's two RLOCs for this EID that I can load split across it. So that's how we could do it with an overlay sort of approach, right? So great question.
This is Albert. Just a small comment complementing what you said. The problem typically with mobile phones is that although multi-homing might be available at the kernel level, they typically hide this kind of functionality and make it transparent to the application level, which means that it's very hard typically to take advantage of that.
I mean, just could we maybe bring back the the map server into the picture to solve these? Or, I mean, that the receiver, since it's behind, well, no. Okay, no, need to.
I mean, I don't know if that helps the problem, right? I mean, you can certainly, okay, so let's entertain that thought. It's a great idea, Mark. If we put a map register functionality on the phone and it registered its EID and joined the group, because what it's doing, it's not only registering its EID that has two interfaces, it's also registering 224.111. When it does that, it can put an RLOC set in that register saying, I have two interfaces. And to the replicator, it looks like two different places where in fact it's the same. But you'll have to do duplicate detection on the receiving end. Now, I've been getting requests from customers, contracts or whatever, that it's nice to send packets both ways. And if we can use the nonce in the Lisp header to detect duplicates and have a small cache, then on receipt, we could drop the packets. Subject for another topic, another IETF.
That's for email.
Yeah, that's for email. So bring it up on email if you want to.
Yeah, actually, that was my comment. So whatever, if you're going to fix that, then for public safety channels, this is not a bug. So keep that option.
Oh, okay. Interesting. Okay, multicast to-do list. Am I okay on time? I only have a couple more slides. Okay. This mobile node must send. Okay, so this was interesting. In this demo, if we ran it long enough, the video stream would stop. It's because the IGMP reports are not being sent periodically from the phone. And the reason is because IGMP reports are only sent in response to IGMP queries. Well, the RTR is not sending IGMP queries periodically, so the reports can't come. So I did implement to send IGMP queries, but we're having a parsing problem now on OR. You probably saw the email. So we don't know. We think that the kernel on iOS could support IGMP queries, but the queries are coming and they have to be associated with the loopback interface versus any physical interface. So that's some work we have to do. We want to keep the stream going. In my applications, I just send, on the containers, I send IGMP reports periodically, so I don't need a querier happening. And I kind of would like to avoid a querier because that's less messages that have to go to the phone. So we would have to write functionality in OOR that once an application on a socket joins a group, that something in the background or adjacent, a sidecar or whatever, that's the popular new term, I guess, is would have to send period, but we'll take that offline. But that's a to-do list thing. Same with MLD for IPv6. So yeah, multicast support for IPv6 is not part of this. I don't know the current status, but we can certainly do IPv6 EIDs and group joining over v4 RLOCs. I don't see any problem. And then maybe do a little bit more research on Lisp-RE to spread the load and reduce replication costs. That's always interesting. Everything has to be head-end replicating because native multicast is not really that available. However, So the guys at Juniper and the M-Bone-D working group are playing around with AMT. And AMT is a tunneling mechanism only supported for multicast. And all this infrastructure on the bottom here, from the yellow dot down, is what they're testing. So they have a multicast native M-Bone, where multicast is native using Juniper and Cisco boxes. And the AMT relay is kind of the head end that replicates packets to AMT gateways, which are usually on mobile devices or any sort of devices. So what we try doing is they said, if you can source some data from a phone from Lisp over on the left-hand side, can we actually connect these infrastructures together? And this is work in progress that we're starting. We just started it last week, and we're going to play with it a little bit this week. But the idea here is for 13 to send multicast to 224.223, and it gets replicated to the two containers as well as an ETR that joins 224.223. So we can decapsulate the packet here and then send it into the multicast native M-Bone. And then the AMT relay forwards it. Now, what's really interesting about this is the packet source for multicast is an EID 13. We did this at the Olympics as well. The problem is this infrastructure can't RPF to 13 because it's not in the core routing tables. So at this dot here, we do Lisp NAT. And what Lisp NAT does is translates the source address from an EID to the address on that interface. And so all these routers here in the native multicast M-Bone are RPFing to this, which will naturally work, right? And so the AMT relay will accept the packets because assuming he defaults or has a specific address to that thing, and then sends it to the receivers. So what we have working right now is the packet sitting somewhere in here, and this guy hasn't received it. So the ball's out of my court. So we're going to talk more about that at M-Bone-D if people are interested. Questions?
Any more questions or comments?
Cable.
Thank you very much.
Sorry, no audio.
And Sharon will use as well the cable.
Oh, he's going to use the cable as well. Okay.
Because of video.
With sound?
No. No production.
We just got to make sure we put it back in.
Yeah.
Okay, so this is a good follow-up to the multicast because this is an edge network, mobility edge network that actually leverages the mobile node multicast significantly. So what I'm going to discuss is the HLisp draft Nexagon. We'll do a quick recap just to baseline what's going on. What is this network? Updates to the draft since the last IETF 105. I'm going to just summarize the value of this Lisp edge network. So it builds on the stability of the BIS and these mechanisms and makes use of Lisp in edge in a time where mobile edge is very hot and needs these capabilities. I will show how. And then given the stability of the base protocol, we'll ask that will make that special edge network, but fairly generic, a working group draft. All right, so the reality is that we have a very low-cost compute in the physical world and a lot of sensors that actually understand what they see. Fixed sensors, cameras, lidars, mobile, meaning patrolling, that enumerate the public space. And this is very useful to many parties. But it needs to be organized. There's so many things patrolling, so many machines, cars, dash cams, native cams, traffic light cams out there. You need to somehow compile this thing so that it can be consumed. And the approach we apply to do that is just to snap what you enumerate to a formal grid of the Earth. You can choose multiple grids. We chose H3 because of its hierarchical nature and hexagonal tiling. Very elegant. And this is addressable by Lisp EIDs. And we're going to show why this is useful. This specific map, you can actually go play with it. I'll send you the URL. It's live New York City right now, including images and enumerations. Okay. As you can see, the enumerations are fairly stabilized since 2 IETFs ago because they're mostly based on BDD, Berkeley Deep Drive Consortium, and the DMV, which is what is the furniture of the road. So that doesn't change much. There's still some reserved for more future features of traffic management of the road, what's called platooning. But for now, this is fairly stable. What we do is snap and pops up the enumerations to an EID addressable grid. The basic unit of this protocol is 64-bit where in the Earth, which tile of the Earth, which square meter you have to say something about, and what, which is 64-bit of what enumeration. Okay, and that's going to be the basic building block for everything. Yes?
This is Dino, really quick question. I noticed that resolution 0 is only 2.6 million miles. That won't cover the Earth. What's the deal there?
No, there's a bunch of routes. You're right. So some of them are hexagons, and I actually had to patch it up with some pentagons, but which are just hexagons with 5.
And you hear about the ocean.
I don't specifically, but maybe some boating application.
Other people can too. Well, I think Uber doesn't care.
If you know, enumerate sharks for surfers, I don't know.
Uber hasn't done its boat service yet?
Shim phrase, man.
I'm stuck in the middle of the ocean. I need an Uber.
Coming soon. All right, so what is the structure of the draft? At the core is a Lisp network able to route these special EIDs. And these special EIDs are EIDs for the Earth tiles and EIDs for clients that protect their privacy, meaning the objects in the network, which are addressable, routable, don't need to know who is it specifically that is interested in that piece of the Earth, meaning disclose their geo-privacy. They just need to know that they're authenticated and authorized, okay? And they have their credentials, but not exactly what is their IP. So these EIDs are routed for a publish, which is a unicast, okay? In which you write to the tile, to the virtual terrestrial piece of land in the edge, and you write it 64-bit where, 64-bit what. It doesn't mean it's going to accept it as reality. It may want few passes. It may correct what you thought is the location, but this is how you publish. You subscribe to multicast channels, just like Dino presented in the other presentation. These are ERD S, G. and you receive updates on what's going on, and it's not a bug if you multi-home and you receive state of your next 20 seconds twice. It's okay, because it's all self-contained in one packet, in each packet. Okay, so here you see a car seeing stuff, understanding what it is, how far it is from where you are, therefore where it is and what it is, can publish, and can subscribe to what's going on beyond the corner. Is there a baby stroller around the corner that somebody else saw? Okay, since IETF 105, we pretty much double-clicked on the technical details of the draft, following very strong demand on the chair.
I said, what's the protocol?
I hope we are at level, at par. Quickly, what we did on the right, that side, which is your left, is a AAA mechanism to get onto the network. So what we do here is make use of diameter, which is very common in mobile network. Typically in non-overlay, you will do something to the gateway, to the P gateway, and it will generate a diameter propagation. Since this is an overlay, you have an IP address, will let you work directly with the diameter for the mobility network. So it's not regular use, but very, very practical, and we make a note of that. So UDNS for the AAA server of the mobility network, the Nexagon network, you get the diameter, you send your credentials, your AVPs, and there is a temporary EID allocated for you based on your credentials before you get it back, along with the RLOC that you're going to use for the RTR, your edge router. It's first cleared with that edge RTR, meaning it's going to expect you, okay? Or multiple, if you want a multi-home, okay? And then you get a reply back, which is, this is your ID for using the mobility network, using this RLOC of your RTR, okay? This way we can load balance and metro and allow for high availability in a very, resilient structure. This is good for a while. So you have to renew that, or the network will be shut off for you. Okay, so that's this picture. These pictures are the unicast and multicast, the publish and what you get when you subscribe. It's basically source dest, so EID source, EID dest, or S, G in multicast, and then some flags, and then the tuples, where, what, key value, key value. There's one flag which is proven to be extremely useful, which is to zip the KV, because the IDs of the tiles are usually in the same area, so they zip very nicely. The values, in the case of an area, somebody breached a red light, the danger covers a lot of area, okay? But it's the same status, same enumeration. And also, there'll be situations many times where some neural networks will just be looking for one thing, just potholes, okay? So whatever they report is going to be consistent. So the object IDs, HIDs are very consistent, and the state is also fairly consistent. Typical zipping is 70–80%. All right. Which means just can push more. Yeah. All right. Well, another thing that happened since last IETF is we have a package on GitHub. I think you still need our permission, so we are giving it. So if you want, you can get it. It still doesn't use OR because the Lisp at the client, if you want to build a client, is still fairly hard way of using Lisp, since all the addressing here is algorithmic, so which makes it very scalable. Based on where you are, you know the EID. You don't need to. So at this point, this is pretty simple. But in addition, the AAA packets, the diameter packets are all encoded in there. You can get the permissions that's full. The part of Lisp we use in the client, which is control plane free, as Dino described, until the RTR is there. And you also get the full edge as all in one, just to debug your client. If you want to start using, you're going to get, if you want to do a navigation app that knows what's behind the corner or knows more things than a typical navigation app does, or you want to play with it, see potholes, see the traffic signs, which you can't see because the tree heights, things like that, you can use that kit. You can also build your own just based on the RFC. There's no additional information needed. RFC draft. Okay, so let me just capture the value of this special Lisp Edge network. It has a broad value. It's worth us taking it on, I think, I hope. The value to munis and Department of Transportation's, government, highway authorities is it's a cheaper, fresher way to survey what's going on. Usually very costly, done every few years, not up to date all the time, and it's budgeted. It has economic value per meter, but this is a way to just let the network gather the information to edge objects, let the objects compile the multiple sources, the multiple passes, the multiple directions, and give you like a survey of signs on the street, what's dimmed, what or went away, you need to repaint, traffic signs beside of the road, these teenager rooms where they have the stop signs. They're taken from somewhere. Lights, side rails, potholes, stop vehicle, which is a big danger. Many times, any stop vehicle will result in death because people just begin to wander around, and it's very expensive to keep patrols just looking for those people stopping because of something and risking their life. Construction zones. Munis love that because they love to give tickets to people who break their permits in time and span. But this is really good for commuters as well, an alert. For drivers and OEM companies, OEMs would like to make money as they drive. They're looking for that source, so there is an economy of data trade, so we can facilitate with an interoperable protocol. Parking assist. This is one of the major challenges of the auto industry. There's no parking. People are hesitant to buy cars. Blockages, slowdowns in the highway. I think you all see dash cam footage last winter of these pileups, which are completely needless. Hard brake situation, sharp turn. Extends the sensor of a car beyond its line of sight, using the network, using the Lisp Edge, and addressable EIDs. Enterprises like UPS are really interested in curbside conditions. Where can they stop? Where cannot stop? What are the truck routes? Pedestrian vehicle density. How many people are in the street? Google Maps wants that. Apple Maps wants that. And we can offer a standard interface to subscribe to that. The 5G Edge is very appealing and make it very relevant. As you can see, you have an aggregation at the edge. that leverages the new 5G technology, and then after processing the consumption, makes it available over any internet or back to the edge. The capabilities in 5G, the new ones, are massive bandwidth, which means you can put all AI in the edge. You can really low cost the dash cams and other sources of informations, even street cams, because it can. But then you have to put that EAD object at the edge. If you're going to put it in Amazon, it's just not going to work. And then ultra reliable low latency, which is the public channels. We don't miss any packets. Even if we have multi-homing and we're going to receive it twice or 3 times, we still don't want to miss any packet, because if there is a red light breach, and I want to get that packet within 1/100th of a second, so I can hear a sound, I can lift my eyes, because otherwise it's dangerous. And that's a demo we did in AT&T. The value of the Lisp as an edge network, as you can see, is that really what happens is that the privacy, the security, the latency control, the subscription, the sharding of the processing is all through Lisp routing. So having a stable standard to do that, having off-the-shelf routers and multiple stacks to control that, and best practices to control that, is really helpful. You can see a note that was sent to the list by AT&T that without this layer 3 option, really, AT&T was facing 2 options, 2 extremes: build a dedicated infrastructure just for that, or have proprietary backends they need to integrate forever for every feature, for every vendor, for every type of client. And we offer something different. One last value point that I scooped from Marco in DMM is that we need to realize that between the edge, the mobile edge and the aggregation, the edge routers, and the mobile clients, there's a whole 3GPP network. And for anything to leverage 5G, there's a bunch of provisioning that has to happen. There's slicing, there's quality of service, there is provisioning that happen. And if we want that provisioning to be efficient, we allow that, we facilitate better, because it's all done based on EAD parsing and all done from edge routers to the EPC. We don't have to mess with application-specific backends. The fact that we put it on Lisp should make it a lot simpler, and there's a lot that you can do. For example, EMBB, if I'm at rush hour or midtown, I don't want to receive that corner all the time unless it's really important. So I can slice it, I can cap it. Okay, I can do provisioning which are important for mobile operators. That's it. The ask is.
Obviously, we'll need an email to the list from you asking for adoption. Are there any comments, questions, concerns? Sri?
Yeah, Srigundavelli, Cisco. One question, can you talk a little bit more on the AAA? You talked about the diameter interface. Can you just talk about the AAA interface, the diameter messages? Yeah, can you tell me exactly, like, yeah.
The diameter, yeah. So you have an IP address, you have IP connectivity, and you want to use specific mobility network. Okay, what you do is you ask for authorization from you first ask DNS, what is my AAA server for this mobility, Nexagon mobility network? You'll get an IP address, okay? And then you ask, that is a diameter server in which you give it your credentials, user, password, vendor, blah, blah. And after some backend, you will get back an EID, which is your overlay address on top of the carrier IP address. Okay, it's a V6 overlay address that you're going to use, and an RLOC, which is a tunnel you're going to use for the edge router.
Right. So before that, there's a SIM-based authentication because I see use the SIM and the password. So is there a authentication to the diameter server from the endpoint?
No, so that's already done by joining the mobile network.
This is not what he's authenticating is not the user as the user of the network. He's authenticating the user as the user of the overlay service.
Okay.
So
that
you
makes
already
sense.
have.
Yeah, okay.
And it is admittedly an unusual use of the AAA protocols because they're normally used inside the network.
Right,
and
that's the part was not clear to me. Okay.
Yes,
Okay.
this is atypical, but seems to work.
Right.
Yes.
Right. Okay. No, I think good stuff. I think I like this work. Yeah.
I have two questions. Did you want to run Lisp within a slice or across slices, or?
Typically, the carrier will provision slices of quality of services as part of the cellular IP network. So the Lisp individual unicast, and everything is unicast. Even the multicast.
So would there be an
is
EID for each slice and a separate mapping system, or would it be across? That's what I'm wondering.
No, the slicing is purely for the EPC.
Okay. And could you go back to slides where you have a nice diagram of the H3 tiles? I don't know if you thought about that. Yeah, that'll work right there. So you have these solid lines around 7. Yeah, right. Perfect. Thank you. You have a hexagon across 2, 4, 6, 7 hexagons. And so what I'm thinking is, have you put much thought about how to join multicast groups when they're per each H3 tile? For instance, that on the bottom right-hand corner, if you look at a node that's right in the very center,
right,
it would actually join a group that would be for that tile that's right in the center. Should that guy join that group as well as all the 6 groups around it? Or should it join to the one group, which is the aggregate of all of them? And what I've noticed with the resolutions, they don't map exactly and fit exactly. So do you have to join 7 groups, the one you're in and all the 6 neighbors? Or have you thought about any of those, how we make that work?
Yeah. So here's the thing. So what you use is a specific resolution for multicast, which is resolution 9, which is like a few blocks.
Okay.
Let's say this, what do you call this place? Raffles City. Okay. And this holds all the tiles. That's EID addressable. The tiles are not, when you hierarchy, there is leftovers. That's correct. And this is the price you pay for having a polygon, which is both approximation of a circle, but tiles and hierarchy. So that's the price you pay. So, but in R9, yes, there'll be some overlaps. But what you will do as the client, because you know where you are, you will register for the R9s which you are in your vector. Okay, you don't have to register
in the direction you're
in where you're going, and this is something that you know as a client. And here the network serves you, but you have awareness
because you realize we might have joint latency as you're. I remember when I worked at Cisco, we did this on battlefield grids, and leaving one square of a grid going to the other, you have to leave to stop receiving data and join the next one. And this has the same problem. It's a joint latency data and state trade-off.
Correct.
And we,
So you join early. If you know where you're going, you join beforehand.
Exactly.
But if you join to a larger grid, then you don't have to leave join.
But
That's the question.
Just postponing
But packets will go to more places, right?
Very similar to handover. I mean, you may join a few just to make sure that you're covered, and that's okay. For the same reason why it's okay for you to receive multi-home, it's all contained. So you'll just get more. Doesn't mean that the application will alert the driver graphically or soundly on everything. It may use judgment, but it will receive a look ahead.
Yeah, I understand. And it depends how soon you start joining, because there is join latency there. Since the join messages, the map registers are UDP messages that can be dropped.
Yes.
And will you get the information soon enough? Do you have to plan multiple tiles ahead of you?
Since it's
the code doesn't know if the driver's going to make a right-hand turn, right?
No, but the client does know its vector. The client that joins does know the driving vector. Okay.
The other thing is there's a distinction between useful to know really promptly and safety critical. And as far as I know, you're not trying to handle safety critical data at all.
Yes. So 1 second ahead of you is irrelevant. That has to be regardless of any network. The car has to deal with it on its own.
So set the plan ahead.
This is 20, 30 seconds heads up.
Transmit a map register in 3 seconds. Is that too late? Are we out of budget?
No,
Not for R9. Not while and not in current mobility technologies.
Now, supersonic fighters might be out of budget, but they got a different set of problems.
That's correct.
I'm
Okay.
thinking of those students that are still in the stop signs. They're on motorcycles going really fast or something.
Really fast is a different scale of really fast.
No, 100, 200 kilometers per hour. That's fine.
Okay? Any other questions? Okay, thank you. I need the connector back. Any other business people want to raise for the LISP working group? Hearing none, please get the blue sheets to Padma. I was going to just click refresh, see if changing things. It's not on. There are different plugins.
No, this is USB. This is something small.
Meet Echo, we messed up the connection. We deliver the sheets to the secretary. Okay, first off, put Luigi's and my name on them.
Okay.
And then deliver them to the secretary, please. I'm going to call Meet Echo. There, we got it. Thank you, Luigi.
What do you usually use? Company.
What's your
TPT.
Huh?
Is the acronym of Telecom Paritaria.
Thank you. So, best one, might show the draft about what are you guys doing different. Submit that as a draft, someday draft. The usual pattern, draft, personal, dash, list, dash, whatever the subject is. You submit that, that'll automatically be visible to you. Then you send a note to the mailing list saying, this draft describes these things, and I'm really interested in feedback. See if we can get some discussion on it. And then when you get to March, if we're preparing for March, you send an email to us, to the list chairs. And that'll copy Padma as well. It helps us with the agenda, saying, I would like to present this material, I'll need 15 minutes.
And what happens if you do some?
Also,